Hello everyone, Sharanya PS here. Welcome back to the session. In the previous video lecture, I have already discussed about functions and different types of the functions. Here, I will be now discussing about a program which makes use of those function concepts. Here, the question asked is, implement using functions to check whether the given number is prime and display appropriate messages. No built-in math function is allowed. This question is a part of C programming lab with the experiment number 7. Here, what is meant by first question is we are asked to write a program which makes use of a function, and the main objective of this program is to check the given number is a prime or not, and it need to print a proper message according to whether the given number is prime or not. And here one more restriction they have given is we should not use any built-in functions. In the sense we have to user defined functions we have to write. So first question here is, what is meant by a prime number? As we know, the prime numbers are the numbers which is greater than 1. 1 will not be considered as a prime number, and the number which is divisible by itself and 1, these numbers we call it as a prime number. That is, the prime numbers will have only two factors, which are 1 and the same number. The examples for like we can take 3, 2, 5, 7, 13, like that. Why all these are prime number? Let us take as a 7. The number 7 will not be divisible by any other numbers. Is it correct? What about the number 5? The 7 is not divisible by any other numbers apart from 1 and 7. Coming to 5. Whether it is divisible by any other number? No, which is divisible by 1 and that number itself. So prime numbers are the natural numbers which will be greater than 1 and that has no positive divisors other than 1 and itself. These numbers we call it as a prime numbers. One more example, we can take it as 13. There is no other numbers which is completely divisible. That is only 1 and 13 are the numbers which will be completely divisible. And if we take 12, what about 12? Here 12 is having 3 is one of the factor and 6 is one more factor and 12 is also one more factor. Here 3 and 6 are by which this 12 is completely divisible. That's why 12 is not considered as a prime numbers. These are the examples for prime number. Now here the question asked is to implement using functions. We have to write the program. And the major condition is to check whether the given number is prime or not and display appropriate message. How we can proceed? We'll look into. First we should begin with the header file. Yes. And then we have to write a function. So we are I will be writing here function prototype, or what we refer as a function declaration. It does not return anything, so we have written it as a void. IsPrime is a function name and it takes one variable, that is number, that is given by the user. And then in the main function I am writing and I am calling the function as well as I am taking the input from the user. I am using two variables here, num and result. Num is a variable which is used to store the number which is entered by the user. Enter an integer number which is asked by the user to enter, and we will be reading that number. Say for example, the user has entered 5. That is the value of num. and we are passing this num to this function is prime. And finally, we will be closing. We have not yet come across this result. We will make use in upcoming code. Then how we can analyze the code? This is one simple logic what we have written in the main. We have just called the function. What is the function name we have written? Is prime is the function name, and the parameter that we pass is a number that will have the value that is entered by the user. Now, what is the logic we have to think of to write inside the function is prime? First, let us look into the concept with one example. I will be taking the number which is entered by the user as 5. So, the variable num will have the value as 5. Next, inside the main function, this as we know, the program will start execution from the main, and inside the main we have written the function call that is prime num. This function will be called with the value of num as 5. So, the is prime function, wherever it is written, that corresponding function definition will be checked and the control will be moved to that. And inside that function, we have to write the logic in such a way that we have to check whether the number is completely divisible. In the sense, the remainder should be equivalent to 0. If at all equal to 0, we say that it is not a prime number. If not, we say it as a prime number. This is the main concept that we have to work out. So, as we know, 0 and 1 will not be a part of this prime numbers. So, we will begin this loop starting from 2 onwards. That is, from 2 onwards, we will be keep checking whether that number is divisible by 2, 3, 4, like that. So, our number is a 5. With the while loop, we are checking whether 5 mod 2. This mod is the special operator which will be returning the remainder. If the remainder is 0, then it says that it is completely divisible. Then we cannot say that the number is a prime number. Here we are checking with that modulus operator. The number is a 5. 5 modulus, here I value is, which started with the 2. 2 is not equal to 0. Yes, 5 mod 2 is nothing but 1. 1 is not equivalent to 0. So, it is going to check with the next number. That's why we are incrementing the I value. Now, I value is nothing but 3. And checks once again whether number is divisible. Number is 5. 5 is divisible by 3. That is, we have to keep checking all the remaining numbers from 2 onwards till that number, whether it is having any remainder as 0. If at all the remainder is 0, then we cannot say that the number is a prime number. That is the logic what we are referring here. While 5 is the number that we are referring, modulus 3 is not equal to 0. Yes, condition is true. So, once again, it is not completely divisible. 5 modulus 3 will return the value 2. 2 is not equal to 0. So, once again, we are incrementing the I value. Now, I value became 4. And we check number 5 mod 4 is not equal to 0. Condition is true. And I value is getting incremented. That is, till 2 to 4, we have not come across any of the number which is completely divisible by that number, which indicates that the number does not have any other factor. And the next, we have increased the I value as 5. So, while number is nothing but 5 mod 5. 5 mod 4 is also 1, which is not equivalent to 0. Next, 5 mod 5, which is nothing but 0 now. 0 is not equal to 0. The condition becomes false. So, it is not going to increment. It will come out of the while loop. Next condition we have to check is whether the number, whatever I value we have come across, whether it is equivalent to number. That is, whether that number is the same number which is completely divisible. As we know, we can say that the number is a prime only if it is divisible by 1 and itself. Here we are clear that it is not divisible by any other number. Now we have to check whether that number is that I value what we have processed, either it is equivalent to 5. If it is true, then we say that the given number 5 is a prime. If not, we write it as the number is not a prime. The corresponding code we have written with the same logic. We have written void. The function we are writing is a is prime, and we are passing the num as a parameter. This is the function definition we write, and we are using one variable I which is starting from 2. That is, from 2 onwards we will keep checking whether there is any factors for that number, and we are incrementing I value each time, and we are checking whether I is double equal to number. That is like after checking whether it is not equal to 0, that is there is no not divisible, then we say that the number is a prime number if I is double equal to number. Else what we say, the number is not a prime number. If we look into one more example here, suppose if he have taken the number, the user has entered the number as 12. Then inside the main function, the isPrime function is called with the value as 12. Control moves to that corresponding function definition isPrime and it processes with this logic. If we look into how it will be proceeded, I will be initially with the 2 and checks with the condition. The number is now 12 mod 2. What is the value? It will be not equal to 0. That is 2 is completely, that is the number is now 12. 12 is completely divisible by 2. So remainder will be equivalent to 0. So this condition what we have written while is becomes false. That is 12 is having the factor, 2 is also a factor. So it comes out and it checks whether that number what we are coming across here is a 2, whether it is equivalent to 2, whether the number that we have come across, whether it is that is what we are divided here, whether this is the number that we are processing. It checks with that. No, it is not. So we say that it is not a prime number. Here we can say it is a prime number only if it is divisible by only that number. That is what we are checking with this if condition. And if we look into this is how we have this while loop is used to check whether there is any other factors for that number, and this if condition is checked whether the factor whatever we obtain, whether it is the same number. If it is same number, then we say that it is a prime. If not, we say that it is not a prime number. That is the logic what we build here. And one more number, let us take it as a 2. The user has entered 2 and the value of num is equivalent to 2 now and checks with the condition 2 mod 2 whether not equal to 0. Yes, it is 2 mod 2 is nothing but 0. This condition becomes false and comes out of the while loop and checks whether 2 is equivalent to 2. That is, here 2 is a number that we are working with and the 2 will have the factors like 1 and 2 itself. That is, which is divisible by 2 and 1 only. That's why we say this 2 is a prime number. So we print that 2 is equivalent to 2. Then we mention that it is a prime. The main process that we do here is the function definition inside that. This is the function header. Void is prime. It does not return any value. That's why we have mentioned it as a void. And parameter it takes is a num. and we are processing with one variable with the value I equal to 2. We have set with the 2 because 1 is 0 and 1 will not be considered as a prime numbers. We will start checking the prime numbers starting from 2 onwards. That's why we have set with the value 2. That is, from 2 onwards we will start whether it is divisible like that. Here with the while loop we are checking whether it is having any factors. From 2 onwards it will keep checking whether that number is completely divisible. If at all it is completely divisible, then we check whether I is double equal to number, that is whether it is the same number. Then we say that it is a prime number. If not, we mention it is not a prime number. And this is what we have written as a function definition. And how would be the output? Here the user will be asking enter an integer number. The user has entered 5. We will get it as 5 is a prime number. Suppose if the user has entered the number as 12. What is the output? 12 is not a prime number. As we look into the entire code, this is how the function is, the program is built by using the function. With the header file stdio.h, we have started the function is prime, and this is the logic what we have discussed now. And inside the main, we have just taking the number from the user and we are calling the function. And the corresponding flowchart here for this program, here we have start with the start, and please note this is how we will be writing the function. Here we in the main, this is we are reading the number, and here this is how we are representing the function. The function name that we write is a is prime with the argument that we are passing is a num, and this is the end of the main function. That's why we have stopped. And the function what we have mentioned here is prime is written separately, because this function we have built as a user defined function separately. That's why when we are mentioning the flowchart, this flowchart need to be separated. This is the main and this is the separate flowchart for function. And inside this is prime function, we have started with the I value setting to 2. And in the while condition we have mentioned by using while representation of a conditional loop. If it is true, I is getting incremented. If it is false, then it will be checking whether I is equivalent to num. If at all equal, then we print that it is a prime number. If not, we will print it as a number is not prime. This is how we can write the corresponding flowchart for the program. If we look into the implementation of this, what we have discussed first, we have begun with the header file, and this is the function what we have written. Since we have written the function prior here, we need not to write the function declaration or prototype. And in the inside the function, we have set with the I value equal to 2. From 2 onwards, we will check whether any number is completely divisible. If it is the given number, with that given number, if any number is completely divisible, then we say that and checks whether that number is equivalent to the given number. Then if at all like that, then we print it as a prime number. Otherwise, we will print it as a not a prime number. And in the main function, we have taken the number and result is not required here. We will just remove that variable. We are taking the user integer value from the user, and with the scanf statement, we are reading that value from the user. And the function is called with passing the number whichever it is entered. This is how we can build the code. If we execute this, if we take some input from the user, say for example, the user has entered 5. So we will be getting 5 is a prime number. And if we run with any other input, say for example 12, for 12, for the very first condition, in the 2 itself it is having the 12 is completely divisible by 2. So we can conclude that it is not a prime number. This is how we can build the logic to check whether the given number is a prime or not. Thank you for listening.